Hello students, welcome to my video lectures on chemistry. In the last lecture, we talked about analyzing the empirical formula. We will now try to look at level 7, determining molecular formula. Your question is, butane has percentage composition of carbon 82.76%, hydrogen 17.24%, and molar mass of 58 grams per mole. The question is, what is the empirical and molecular formula? Write the steps and solve the problem. So here carbon is 82.76% and hydrogen is 17.24%. So let's imagine out of 100, we have 82.76 grams of carbon. So 82.76 grams of carbon divided by the molar mass of carbon, that gives you 6.89 moles. For hydrogen, it is 17.24 divided by 1.01. That gives you 17.66 moles. Now, we divide these with the smallest numbers. Obviously, we divide each one of them by 6.89. And here you get the ratio 1, and 17.66 divided by 6.89 gives you 2.47, which could be rounded to 2.5. Now the ratio is 1:2.5. So obviously you can't have a decimal, so you will multiply 2 on both sides. So the ratio would be 2:5. So your empirical formula is C2H5. And empirical formula mass would be carbon 12 times 2, that is 24, plus 5, which is 29. So your empirical formula mass is 29. Your molar mass is 58 grams per mole. So what you do is you divide the molar mass divided by the empirical formula mass, and that you get as 2. In order to find the molecular formula, you multiply 2 to your empirical formula, so you get C4H10. So your answer is going to be C4H10. And look at level 7. Determining limiting reactants and calculating the theoretical yield. So you are given the following. You are given the equation 2Fe3Cl2 is 2FeCl3. Now, good thing here, the equation is balanced. Many times you will have a question where the equations are not balanced. So your job should be to first balance the equation. This question, you are fine. So first, let's find the moles of iron. So you have 28 grams of iron, 28 divided by the molar mass, that is 55.845, which is 0.501. Then moles of chlorine, that is 28 divided by 70.906, which is 0.394. Now, in order to find the limiting reagent or limiting reactant, what you do is you divide the moles with the coefficient. So here you see you are dividing the moles with the coefficient 0.501 divided by 2, and the other one is 0.394 divided by 3. And the smallest number would be the limiting reactant. So in this case here, this is 0.1313 and this is 0.2505. Obviously, this is smaller. So your chlorine is your limiting reactant. So chlorine is going to decide how much iron chloride will be formed. So ferric chloride, that's FeCl3, would be formed. So you have the formula, that is the mass divided by the molar mass multiplied by the coefficient. So when you have any reaction, this formula has been discussed in class. Your mass divided by the molar mass multiplied by the coefficient should be equal to the mass of the other compound divided by the molar mass multiplied by the coefficient. So in this case, we are trying to see the theoretical yield. So we are trying to find what percentage of FeCl3 is formed. So if you see 28 grams of iron, 28 grams of chlorine, 28 grams of chlorine divided by 3, 3 is the coefficient, multiplied by 70.906, that is X which we don't know, divided by 2, multiplied by 162.2. That's the molecular formula for FeCl3. And you solve for X. When you solve for X, you get 42.7 grams. So 42.7 grams is your theoretical yield. So this is how you calculate the theoretical yield. Now, the question is, what was the percentage yield? So once you have the theoretical yield and you have the actual yield, your actual yield is 39 grams. So you have 39 divided by 42.7 multiplied by 100, and that gives you your percentage yield. So that's 91.3%. So your answer is going to be 91.3%. Then this was one model paper, criteria A practice paper. We'll go over some of the questions in this video. The first question is again on balancing. So you had C4H10, O2, CO2, H2O. So in the process of balancing, first you see there are 4 C's. So I put 4 here. So that balances C. Then hydrogen was 10. So I put 5 here. So that balances hydrogen. But now we have 8 plus 5, 13 oxygen. And here I can multiply 6.5 to get 13, but you cannot have a decimal. So what you're going to do is you're going to multiply everything by 2. So this 1 multiplied by 2, that gives you 2. 6.5 multiplied by 2, that gives you 13. 4 multiplied by 2 gives you 8, and 5 multiplied by 2 gives you 10. So your final balance equation would be 2C4H10 plus 13O2 is 8CO2 plus 10H2O. Second one, you had CuCl2 plus NaOH is CuOH twice plus NaCl. Now, if I see here, I have 2 chlorine here, and here there was 1 chlorine. So first thing what I did was I balanced chlorine. I put 2 here, and my chlorine is balanced. But in doing so, I changed the number of sodium. So my sodium is 2, so I can put 2 here. So my sodium is balanced. Now, if I see I have 2 oxygen, so I have 2 oxygen. So this is 2 oxygen, 2 hydrogen, and this equation is balanced now. Question number 2, calculate the molar mass of copper 2 nitrate. So you're supposed to find the molar mass of copper 2 nitrate. Copper is 63.55. Nitrogen is 2, so 2 times 14.01. And oxygen is 6, 6 times 15.99. That gives you 187.51. And that's the molar mass of copper 2 nitrate. Then level 3 questions. An experiment was carried out to find the molar mass of vitamin C. It was found that 1 gram of vitamin C contained 0.00568 moles of vitamin C. Calculate the molar mass of vitamin C. So this is more a math problem. If you see, you have 0.00568 moles of vitamin C is equal to 1 gram. And all you have to do is how much is 1 mole of vitamin C. So since you have 0.00568 moles of vitamin C as 1 gram, so 1 mole of vitamin C would be 1 divided by 1.00568. And that gives you 17.06 gram per mole. So calculate the molar mass of vitamin C. That is 17.06 gram per mole. Now, how many particles of vitamin C would be found in 1 gram of vitamin C? So if you see 1 gram of vitamin C has 0.00568 moles, and 1 mole has the Avogadro's number. So you multiply the number of moles with the Avogadro's number, which is 6.02 times 10 raised to the power 23, and that would give you the number of particles. So you get 3.42 times 10 raised to the power 21 particles. Now, level 5 and 6, questions on limiting reactants or limiting reagents. So ammonia reacts with unlimited amount of oxygen gas to produce nitrogen. What mass of oxygen is needed to convert 1.02 times 10 raised to the power 2 grams of ammonia to nitrogen? So first thing, whenever you get a question like this, is to balance this equation. If you solve the entire equation and don't balance it, your answer would be wrong. Sometimes they would give you the balanced equation in the question, sometimes they wouldn't. So your first job is to look if the equation is balanced or not. In this case, the equation was not balanced. So first what I did was I balanced the equation. And so when we balance, we get 4NH3 plus 3O2 is twice N2 plus 6 water. Now remember the formula we had discussed about the mass of any object or any reactant divided by the coefficient multiplied by the molar mass would be equal to the mass of the other reactant divided by the coefficient times the molar mass. So here the question is what mass of oxygen is needed to convert 1.02 times 10 to the power 2 grams of ammonia into nitrogen. So we are talking about these two. So the mass of ammonia given is 1.02 times 10 to the power 2 divided by the coefficient, which is 4, divided by the molar mass, which is 17. And for oxygen, we don't know the mass, so I'm assuming that as X divided by 3, the coefficient, multiplied by the molar mass, and just solve for X, and you'll get 144 grams. Now, have a look at this question, level 5-6. Iron is extracted from iron oxide as shown. So you are given this formula, equation. So first you need to do is to balance the equation. And the question was to calculate the maximum theoretical mass of iron that could be produced from 1 times 10 to the power 4 kg of iron oxide in presence of unlimited amount of carbon monoxide, CO. So let's say the amount of iron. So here we are looking at iron oxide and iron. So let's say we have X amount of iron divided by 2, which is the coefficient, multiplied by the molar mass of iron, which is 55.84. That is equal to the mass of iron oxide, which is given to be 1 times 10 raised to the power 4, but that's in kg, so you convert it into grams. So 1 times 10 raised to the power 7 divided by the coefficient, which is 1 times the molar mass, which is going to be 159.69. That's the molar mass of Fe2O3. You solve for X and you get 6.99 times 10 raised to the power 6 grams. Now in the reaction, only 1.5 times 10 raised to the power 5 grams of iron was produced. Calculate the percentage yield. So your actual yield is 1.5 times 10 raised to the power 5. So 1.5 times 10 raised to the power 5 divided by the theoretical multiplied by 100, and that gives you 2.14%. Okay, good luck with these questions. We will discuss the next question in our next video.